A uniform metallic wire has a resistance of 18 ohms and is bent into an equilateral triangle. Then the resistance between any two vertices of the triangle is. Alright. So what we have over here is a uniform wire, and this wire is of a certain length. The length is not specified, but the resistance of this wire is 18 ohms. Now this wire is bent into, this wire is now essentially bent into an equilateral triangle. So let us say this is the situation. This is now bent into an equilateral triangle. So each of the three sides of the wire can be represented by a particular resistance. Let us say this side will have a particular resistance R. So will this side. And since it's an equilateral triangle and the net resistance of the initial wire was 18, it is very easily understood that the resistance of each of these three sides is going to be 6 ohms each. Now what they are asking us to do is to calculate the resistance between any two points or any two vertices of the triangle. So let us say we are taking these two vertices. Alright, so herein we have got a 6 ohm resistor connected. Here also we have got 6 ohm and 6 ohm. So this particular circuit is equivalent to the circuit that is simply a parallel connection, and in this particular parallel connection one resistor over here is, let us say, 6 ohms. So this particular resistor is 6 ohms and the resistance over here is 12 ohms. And let us say this is the point A and this is the point B. This point A is represented over here and point B is represented over here. Now we can use the formula for resistances in parallel. 1 upon R parallel is equal to 1 upon R1 plus 1 upon R2. So this is a very simple question and this is a very simple equation that one and all should know how to solve. You will get resistances in parallel are given as R1 R2 upon R1 plus R2. Alright, so here substituting values that are present in this particular question, we get R1 R2 to be equal to 12 into 6 and R1 plus R2 is 12 plus 6, that is 18. So this is simply 3 and this is 2 and this is simply 1 and this is 2. So the answer is going to be equal to 4 ohms. So that is option A.